So if you recall, in the last lecture, we were discussing the Wireshark's UI and the packets that were captured and the headers, okay? Now in this lecture, we're going to discuss something which is very interesting and which is the display filters. So if you see here, you can already see the display filters. What does a display filter mean? So usually what happens is that since we don't have a lot of traffic here, but in real networks, you're going to see hundreds of thousands of packets. And sometimes you want to focus on specific things. Like for example, you may want to just view packets for a certain protocol. For example, HTTP packets, TCP packets, maybe ICMP packets. Or sometimes you want to focus on packets coming from a source IP, going to a specific IP, going to a specific port, using a certain protocol. So all of those things are done via the display filter. Now you need to understand there are two basic type of filters. One is this display filter. So all of the traffic is there, but if we apply a display filter, Wireshark is going to filter the output and just show us the packets that we want, okay? Depending on whatever filter you have applied. There is another type of filter also, which is called a capture filter. Now capture filter is different in the sense that it specifies what type of traffic you want to capture. So that's the fundamental difference, okay? In display filter, whatever you have captured is still there. You're just showing or filtering, or you just want to focus on certain things, but the traffic is there. All the packets and the data is there. However, if you change the capture filter and you specify, for example, I just want, let's say, TCP packets, then Wireshark is just going to capture that specific traffic itself. And then later on, again, you can again apply display filters within that output. Okay, so that's the main difference. Display filters just for displaying, capture filters what you want Wireshark to capture. Now before we proceed, let me just quickly go over what are the different display filter options and commands and how you can use them in Wireshark. So the structure is a bit similar to what we have already been doing. So for example, if you just want to filter and just see packets coming from a particular source IP address, you can do ip.source equals to and then the IP address. And then Wireshark is going to hide all the packets and just show you the packets which are coming from this source IP address. Similarly, you can also filter by destination IP address, in which case you need to do ip.dst equal to and then the destination IP address. So Wireshark is going to filter and just show you the packets which are going to this IP address. Also, you can filter by TCP port, for example. So it will be tcp.port equal to 443. Now this means it can be going to port 443 or coming from 443, okay? However, if you want just the destination port TCP 443, then you need to do tcp.destination port. So one rule of thumb which you can sort of like remember when discussing display filters or when using display filters is that you always specify the protocol first. So for example, IP protocol, IP, TCP, TCP, UDP, DNS, HTTP. So it always starts with the protocol name. So the next is filter by source UDP port. So udp.source port equal to 8080. So this means that all of the traffic which is originating from UDP source port 8080 will be filtered and shown. Similarly, you can filter by protocol. You can put DNS, you can put ICMP, you can put HTTP, you can put TCP, UDP, whatever you want. However, Wireshark is much more powerful. You can even put filters on the HTTP packet headers. So for example, if you want to see if someone has visited www.google.com, then you can say, does the HTTP header contain this one? So this could be going to or coming from. However, if you want to, for example, check all of the different websites, such as, for example, mail.google.com or anything that contains Google, you can even specify. So this was an exact match, but this just means that the header should contain this word. That's it. It could be mail.google.com, it could be www.google.com or any other combination, google.docs.com, for example. So already you can see that Wireshark is very flexible and very powerful. One more thing which you can do is that you can also combine filters. So just like we did previously for TCP dump and snort, for example, so you can also combine filters. So for the OR, you can use the two pipes, okay? So this means that it is a logical OR operator and you want traffic which has TCP port 80 or TCP port 443. Now, for example, this particular combination could be useful if you want to check all of the traffic going to a web server. So for example, if it is the HTTP plain text protocol, which we have been discussing throughout the course, which is insecure because it transmits everything in plain text, then the traffic would be coming or going to port 80. However, if you're using the HTTPS, which is the encrypted version, HTTP secure, then the traffic would be going to port 443. So for example, this OR can be used if you're not sure. You know that there is a web server to which some traffic is going on and you want to monitor all the traffic, but you're not sure, for example, is the web using HTTP protocol or is the web server using HTTPS? So you can combine these, either this or this. Similarly, you can also have the AND operator, which is the logical AND, which basically means that source IP should be this one and the destination IP should be this one. And by the way, there's a small typo. This is DST, not DEST. So this means that IP source, so this should be coming from this IP address and going to this IP address. Similarly, you can also use the XOR operator, which is a bit weird one. So just to explain, so in OR, either this could be true or this could be true, right? But in XOR, this has to be true or this has to be true. If both are true, then this becomes false again. Anyways, we also have the NOT operator, basically not true. So for example, you want to see all of the traffic except that involving IP address this one, then you're going to see all of the traffic that doesn't include this one. Similarly, you can also do, for example, not ICMP, which basically means that I want to see all of the traffic except that one involving ICMP protocol. So lots of different combinations, very powerful. Now let me go back to Kali Linux and show these things in action. So coming back to the lab, now we are going to apply a couple of these filters here. So we just want the source IP address to be coming from Kali Linux VM 0.1. There you go. So now you're just going to see all of the traffic which is coming from Kali Linux VM. Similarly, you can also say, for example, all of the traffic going to the destination Nginx web container, for example, okay? The same one, okay? Because in all of these, the destination was this one. But just to check, you can also change. For example, any traffic going to destination 172.17.01 going to the Kali Linux VM. So this is the traffic coming from Nginx container and going to the Kali Linux VM. Now let's filter by TCP port. Now, if you recall, we had this nmap scan where we tried to scan port 80, okay? This one, port 80, which was a TCP packet. Now we can say TCP dot destination port equal to 80. There you go. This is just going to show you those specific packets. So this was basically an nmap scan from Kali Linux VM to Nginx container using TCP. So we are seeing two different packets here. And once again, you can always basically analyze the headers. For example, source port was this one, destination port was 80. What was the IP protocol? You had this IP address source, this is the destination, and so on and so forth. Now, another interesting combination which you can do is just to filter based on protocol. So let's say I just want to see all of the packet related to ICMP protocol. There you go. You're just going to see all of the traffic which involves the ICMP protocol, which is usually used in ping, right? So that's why you're seeing the request packet and the reply packet. So similarly, you can also combine filters. Like for example, I can say, let's say I just want to see this one, the echo reply. So I can say ICMP and IP.destination equal to 172.17.0.1 because we just want the reply traffic. Okay, so you're just seeing the echo reply, which is going from Nginx container 17.0.2 going to Kali Linux VM 17.0.1. ICMP traffic, ping, echo reply. So you have lots of different combinations. Another example could be, let's say I want to see all of the protocols except ICMP protocol. Okay. So now you're not going to see any packet from the ICMP protocol. You're just seeing TCP. Let's say I say not TCP. Okay. So once again, you're going to see all of the different protocols except the TCP protocol. So that's how you have so many different powerful combinations which you can leverage and conduct forensic investigations in much more detail and with a lot of flexibility. Now we also discussed the HTTP protocol headers, right? You can also basically check if someone visited a specific website, for example. So for that one, let's just open a browser window and let's quickly visit the Nginx container 172.17.0.2. There you go. And let me just close it because otherwise it's going to generate a lot of traffic. Okay, let me remove the filter. Let's go to the default one. And there you go. We are starting to see the HTTP header. So just to keep things clean, let's just focus on HTTP protocol. There you go. So now you're just seeing HTTP packets. And this is the one coming from Kali Linux VM going to Nginx container. And this is the reply coming from Nginx container to Kali Linux VM. And obviously you can also see the headers. Now, previously we saw the headers. For example, we discussed transport headers, destination port, and the internet protocol header. So for example, just to see here, so you can see here already, for example, for this one, the coming from Kali Linux going to the container, you can see source was this one, destination port was 80, and IP address was this one, and destination was this one. Okay, but in addition to that, now you're also seeing the HTTP protocol, which is on the application layer. So in HTTP protocol, you have a couple of operations. So when you open a website, so usually it's a get HTTP. When you submit, let's say login details and you press submit, it's a post operation. And here you can see a lot of more details also. Like for example, what is the host? What's the end destination? And then what's the user agent? And then several different fields of the header. Similarly, in the response also, you can check the HTTP protocol header. This is the response 200 OK basically means that the page was correctly loaded. Something was returned. And Nginx is the server. You have the date timestamp, content length, and everything. So wonderful. So now let's see if we can check. So basically, what do we want? We want to trace this packet. So now if you recall, you can also use HTTP host, HTTP, for example, http.host. So you can say http.host equal to. So which one do you want? Do you want the one going to the destination or do you want the one returning? So let's say we're interested in the packet going from Kali Linux VM to Nginx container. So we will just put the destination IP address .2 and we're going to see just this one, okay, which is the original request. And there are so many other options also. So for example, you can say, I just want to see HTTP request packets. There you go. You're just going to see the request coming from Kali Linux going to Nginx container. Similarly, you can also say, I just want to see the response packets. And then you can also say, for example, let's say I'm interested in seeing what were the get requests, all the get requests done, okay? So for example, here you can see this is the get request. So you need to put http.request.method equal to get. There you go, this one. So you have so many different combinations possible. And once again, you can always combine different filters, right? So for example, you can put ip.source equal to, let's say 172.17.0.1 coming from Kali Linux VM. So similarly, you can also change this to 2. Okay, so now you're just going to see the reply message. And there are so many different combinations possible.